The Milky Way alone contains somewhere between 100 and 400 billion stars. Around most of those stars orbits at least one planet. And in our galaxy, scientists estimate there could be as many as 40 billion Earth-sized worlds sitting in the so-called habitable zone. Not too hot, not too cold, where liquid water can exist. The numbers are almost incomprehensible. So here is the question that has haunted scientists, philosophers, and governments for over 60 years. Where is everybody? In the summer of 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. The conversation turned, as it often did in those days, to the strange and the speculative. They were discussing a recent cartoon about aliens. And somewhere between the main course and dessert, Fermi posed a question that nobody could answer. If the universe is so vast and so old, and the conditions for life appear to exist in billions of places across the cosmos, then why haven't we seen any evidence of it? Why haven't we been visited? Why haven't we picked up a signal? His colleagues fell silent, because they didn't have an answer. And here's the remarkable thing: neither does anyone else. Not in 1950, not today. This is the Fermi Paradox, and depending on how it's resolved, it may be the most important question in the history of our species. To understand why the Fermi Paradox is so unsettling, you need to appreciate just how old and how large the universe is. The universe is approximately 13.8 billion years old. Our solar system formed around 4.6 billion years ago. Life appeared on Earth roughly 3.8 billion years ago. And modern humans, Homo sapiens, have existed for only around 300,000 years. On a cosmic timescale, we are extraordinarily new. But here is what makes this strange. If even one civilization had emerged in our galaxy just a few million years before us, which on a 13 billion year timescale is nothing, and if that civilization had developed interstellar travel, even at a fraction of the speed of light, they could have colonized the entire Milky Way many times over by now. A few million years. That sounds like a long time. But our galaxy has been forming stars for over 10 billion years. There has been time, extraordinary amounts of time, for something to emerge, expand, and make its presence known. And yet, nothing. No signals, no visitors, no megastructures in the sky, no alien probes floating quietly through our solar system. Just silence. In 1961, astrophysicist Frank Drake tried to make the question more rigorous. He devised what became known as the Drake equation, a formula that attempts to estimate how many communicating civilizations might exist in the Milky Way at any given moment. The equation multiplies together a series of factors: the rate of star formation in our galaxy, the fraction of those stars with planets, the number of planets per system that could support life, the fraction where life actually develops, the fraction where intelligent life emerges, the fraction that develop detectable technology, and finally, how long such civilizations survive before going silent. Drake's own estimate, using the best data available at the time, suggested that there could be anywhere from 1,000 to 100 million communicating civilizations in the Milky Way right now. And yet, we've found none. The equation doesn't solve the paradox, it sharpens it. Because if even the most conservative estimates are even slightly correct, the silence becomes very hard to explain. Over the decades, scientists and philosophers have proposed dozens of explanations for the Fermi Paradox. The first, they're too far away. The universe is simply too vast. Even travelling at a significant fraction of the speed of light, crossing the galaxy would take millions of years. Perhaps we're just too far apart and the signals haven't reached us yet. This is possible, but it doesn't explain why we've detected no electromagnetic signals in 60 years of searching. The second, they're avoiding us. Known as the zoo hypothesis, perhaps advanced civilizations are aware of us but have chosen not to interfere, watching, waiting, leaving us to develop on our own. It's a compelling idea, but it requires every single civilization in the galaxy to have agreed to this policy. One rogue actor breaking the rules would be enough to make contact. The silence of every species, everywhere, for all of recorded history, is hard to explain this way. The third, they're already here, and we haven't recognized them. Some researchers have suggested that alien intelligence might not look like anything we'd recognize. Not radio signals, not spacecraft. Perhaps something embedded in mathematics or biology, or even something operating on timescales far beyond human perception. We may be too limited to notice. The fourth, and perhaps the most chilling, is the Great Filter. The idea, proposed by economist Robin Hanson in 1998, is that somewhere along the path from simple chemistry to spacefaring civilization, there is a filter, a barrier so difficult to pass that almost nothing makes it through. The crucial question is whether that filter lies behind us or ahead of us. If the Great Filter is behind us, if the emergence of complex life or multicellular organisms or intelligence is extraordinarily rare, then we may be among the first civilizations to have made it this far. And that, in a strange way, is good news. But if the Great Filter lies ahead of us, if civilizations routinely reach our level and then destroy themselves through war or climate catastrophe or technologies they cannot control, then we may be approaching the most dangerous moment in our history without knowing it. Since 1960, humanity has been actively listening. The SETI Institute, the Search for Extraterrestrial Intelligence, has scanned millions of star systems for anomalous signals. In that time, we have found precisely one candidate worth discussing. On August 15, 1977, a radio telescope in Ohio detected a 72-second burst of electromagnetic energy so unusual that the astronomer reviewing the data circled it and wrote in red pen a single word: "Wow." The WOW signal, as it became known, came from the direction of the constellation Sagittarius, at a frequency long considered ideal for interstellar communication. It has never been detected again. It has never been explained. In 2016, astronomers observed a star called KIC 8462852, nicknamed Tabby's star, dimming in patterns that no known natural phenomenon could account for. Some researchers, cautiously, suggested the possibility of a Dyson sphere, a megastructure built by an advanced civilization to harvest a star's energy. Later analysis suggested more mundane explanations, but the star still behaves strangely. These are data points, curious ones, but not proof. The silence continues. The Fermi Paradox doesn't have a resolution, not yet. It may be that life is vanishingly rare, that the emergence of intelligent, communicating beings requires such an extraordinary alignment of circumstances that we are, effectively, alone in the observable universe. The silence would then be exactly what you'd expect. Or it may be that life is common, but civilizations are fragile, that they rise, reach for the stars, and then go quiet, for reasons we are yet to understand, but may one day face ourselves. Or perhaps the answer is something stranger still, something we haven't thought of yet. What we do know is this: we are a young species on a small planet in one arm of an average galaxy, in a universe of almost incomprehensible scale. We have been asking this question for less than a century. Perhaps we simply haven't been listening long enough. If this is the kind of question that keeps you up at night, you're in exactly the right place. I'm the Fermi Hour. Subscribe, and next week we go deeper. If you want to understand the science behind what you just watched, the Drake equation, the Fermi Paradox, and the maths of the cosmos, I'd highly recommend Brilliant.org. They have incredible interactive courses on astronomy, logic, and scientific thinking. I'll leave a link in the description. The first 30 days are completely free. Next week on the Fermi Hour, something was detected at the edge of our solar system, and nobody can explain it. I'll see you then.